Good morning. So today we're going to do systems of equations by graphing. You are not actually going to be graphing these equations because unfortunately on Google Forms and slides it's very hard to graph. So I am just going to show you how it would be graphed, and then you're going to analyze the solutions given a graph. So please complete your do now, watch this video, and then complete the Google Forms systems of equations by graphing. And when you're done, complete the reflection for the day. So when you graph the equation, the point in which the two lines intersect is the solution. So we start with a 3 on the y. We're going up 1 over 2 for the first. And then for the second equation, we start at the 6. It's a slope of up 1 over 1. The solution is the point where they intersect. So it's negative 2, 4. Okay, let me show you one more, and then I'll talk about how to analyze these graphs. So you start at 7, it's up 1 over 1, 2, 3 because it's negative. The second line, you start at a positive 1. Hold on one second. Let me do the first one over. So you start at 7, it's up 1 over 1, 2, 3. The second line, you start at 1, it's up 1, 2 over 1, 2, 3. The solution is where they intersect, so it's 6, 5. Okay, so by looking at a graph of a system of equations, if the lines intersect at one point, they have one solution. If the lines are parallel, meaning their slopes are the same, there is no solution. And if the two lines together are the exact same, there's infinitely many solutions because this line has many points. So on today's form, you're going to be analyzing graphs. You will notice these two lines, when graphed, they are the exact same. So in this case, this systems of equations has infinitely many solutions. There are many points on this line, and any point on the line would work. If you look at the next two graphs for these systems, they're both graphed. They intersect, and the point in which they intersect is the solution. So this has one solution, and the solution is 5, 1. And you could sub that back in and see if it works. So it's one solution, and the solution is 5, 1. So you will notice the next systems of equations wound up being parallel lines. So they had the same slope, and parallel lines will never meet. So in this case, this system, there is no solution. Now we're just going to look at the slope to determine if it has one solution, no solution, or infinitely many. And in this case, the slopes are the same, right? It's both negative 1, so they are parallel. And there's going to be no solution, okay? If we look at the second one, in order to do it, we are going to have to change the second equation. So it's going to be y equals negative 5x plus 0. Then we will notice the slopes are the same, right? They're both a negative 5. So once again, these are parallel and there's no solution. The last one, we have to change both just to compare. So if we get negative 2y equals negative x plus 10, we get y equals 1/2 x minus 5, and then the other one would be 3y equals negative 2x minus 1. We get y equals negative 2/3 x minus 1/3. And it doesn't really matter. The whole point here is you want to look at the slopes of the lines. And in this case, the slopes are not the same. So being they're not the same, there is going to be one solution. There will be a value for x and a value for y. Okay, so please try your best. If you need help, it's best you join Zoom. A few pointers to remember: if the lines, if they intersect, it's one solution. The slopes will be different. If they are parallel, the slopes are the same. There is no solution. Parallel lines never meet. Okay, and the last thing, obviously, if they are the same line, there's infinitely many solutions. If you need help, it's best you join Zoom at 11:30 a.m. Use the link you received in your email. Remember, solutions to systems are always listed as ordered pairs. So in the form, please list it as an ordered pair, X, Y, in parentheses, no spaces.